This session is being recorded, and thank you and welcome to everybody to our 8th out of 10. I cannot believe we're already at our 8th out of 10 webinars. We hope that you will consider joining us on October 10th when we talk about ground validation and how we ensure that this data that we're collecting from space is accurate, and often the algorithms need to be modified, or maybe I should just say always, the algorithms need to be modified to ensure that they're accurately measuring all around the world the amount of precipitation that's falling. So that's going to be a really, really interesting webinar as well, and that is on Thursday, October 10th, same time, different channel. We'll tell you, we'll have information about that later. So tonight we're going to be focusing on the applications, the ways in which data from our GPM mission is being used to enable people to better understand how water moves through our planet and to help make informed decisions that lead to improved outcomes for society. We have 3 key speakers this evening. First, we're going to be hearing from Andrea Portier, and she is my colleague and my left hand, and I'm left-handed, over at Goddard Space Flight Center. And she is the applications lead for the Global Precipitation Measurement Mission. In this role, Andrea engages with different stakeholder committees and communities, and she works to understand how GPM data products are being applied for decision-making, as well as to promote and educate potential users about NASA's precipitation data and how it can benefit their work and their lives. After we have Andrea, then we're going to be hearing from Anita LeRoy. Anita splits her time between research to operation activities like conducting product assessments and developing training, got to flip my page here, and training research with a focus on applications of and novel methods for utilizing Earth-observing satellite data. As a NASA short-term prediction, research, and transition center, who knew, the acronym for that, thank goodness for acronyms, is SPORT, S-P-O-R-T, liaison. Ms. LeRoy works closely with forecasters and product developers, evaluating experimental data sets and operational products, and developing training for new products and methods. So we're in good hands there. And then we're going to finish up with our dear friend and fellow part of the Precipitation Measurement Mission scientist, Dr. Vasco Mantas, and he leads the Earth Observation Laboratory at the University of Coimbra in Portugal and is an international member of NASA's Precipitation Measurement Mission Science Team. His research focuses on land surface atmosphere interactions and change processes, harnessing diverse Earth observation data with user needs and requirements. He regularly conducts ground validation and product characterization activities. And so with that, my friends, I want to remind you that I will be sharing the link for our resource packet regularly as we have the chat here. And so many of the things they're going to be talking about will be in this resource packet, and I will be listening out for anything I might be missing, and I can add that to the resource packet tomorrow. So without further ado, Andrea, the floor is yours.
Thanks, Dorian. I will share my screen.
And I'll wait and let you know that I can see it before I mute.
Perfect. Just got to put it on presentation mode.
And right now, we need one more click, I think, to get presentation.
Yeah, thanks.
Got it. Perfect.
But you can see it, though, in full.
It's beautiful. Yep, we got it.
All right. Okay, well, thank you so much, Dorian. This webinar is, of course, near and dear to my heart because it's focused on applications, and I really do appreciate the opportunity to talk about this with all of you. I am very excited to talk about really the cool ways that GPM data is used, not just for research, but for actual societal decision-making that impacts communities from the local, regional to global scale. And so what I want to do is help paint a picture of all the cool capabilities that users are using, how users are using GPM data for decision making. So let's get started. I know there's been several of these webinars, but I want to bring back and just shed light on the GPM mission, or the Global Precipitation Measurement Mission. The fantastic thing about the GPM mission is it provides global precipitation. And so what you see here is an animation of one of our data products, iMerge. But right now, I just want you to focus that this is near global precipitation. You see in the tropics, small scattered storms moving westward, but also you started to see, I'm going to see if I can start it back. Yeah, the development of 4 hurricanes that were developing across that area. And then also actually a typhoon in the Pacific. But you do see also these large but less intense systems in the mid-latitudes, as well as frozen precipitation in the poles. This can give us a range of information about what is needed and how it impacts us and where we live. Okay, so why is knowing about precipitation important? I think we all can say this, but knowing where, when, and the amount of precipitation can help support a range of applications. And when I talk about applications, we're talking about how people are using this to solve big problems right here on Earth, from ecological management to water resources and agriculture, renewable energy and infrastructure development, to disasters monitoring and response, to public health from vector and waterborne diseases, to even weather forecasting and climate modeling efforts. So you may be wondering, where have people accessed GPM data and used it for research and applications? Well, we have users all throughout the world, on almost every continent, with the exception of Antarctica. But we have so many users that rely on GPM data. Why? Because it not only provides timely precipitation data, but we have a longer term record of data from over 24 years now of precipitation data that can be very useful for societal decision making. So what I want to do now, because we're GPM's 10th anniversary, that is why we're having these webinar series, is give you 10 highlights of 10 applications. I thought that sounded fitting. And just to start the dialogue on some of the cool uses of GPM data. So first up, for highlight number 1, I chose tracking elephant migrations in India. Why is this an actual application? Well, there's been an increase in human-elephant conflict, meaning that humans are harming elephants, but also elephants are harming humans. Why? They're starting to see that elephants are naturally migrating into where humans live, and that creates a problem. Elephants raid crops, eat the food that humans rely on, but also they raid infrastructure that humans live. So humans wouldn't want to protect it, but also elephants want to protect themselves. So that creates an issue. So we have animal conservationists that are really trying to understand where these elephants are migrating to and why. Is it because of food, water? And so understanding different weather, but also ecological parameters. So monitoring changes in precipitation could help understand why elephants are migrating, what cues they use, and how they respond to environmental changes. Precipitation data from GPM is not the only data set they're using. They're using Landsat data to look at crop information, but even looking at forest cover throughout India to see where these elephants are going. All of this can be essential to provide early warning and provide educational tools to communities that may be impacted by elephant migrations. All right, to highlight number 2, I'm going to shift to the water resources and agriculture side. We have researchers at the University of Washington in the United States that are working directly with farmers, actually specifically the Bangladesh Department of Agriculture, to develop an operational system for irrigation advisories. And so why they're doing that is that they want to address user needs directly. Why? Because they want their users to use this information directly for them in their location. So what's interesting is that they're combining precipitation data with a handful of other data to see when these farmers should irrigate their land or not, based on precipitation data and crop information. But what farmers want is not just, a lot of rainfall data. They want to know yes or no of when they should water their crops via cell phone alerts. And that's exactly what this researcher teamed up with the Department of Agriculture to do, is develop a system where it sends farmers direct text of when to irrigate their crops. This has helped conserve critical freshwater resources in the region. Because of this application, they're looking at anticipated positive long-term impact from a 30% reduction in irrigation water use to a decreased rate of groundwater table decline during the January through June months, to even over $100 million in US dollars per year in fossil savings and for fossil subsidies, but even reducing CO2 emissions in the area. It's incredible what people can do with satellite data. All right, so keeping with the water resource theme, I'm now going to go all the way from Bangladesh to the United States and the southwestern portion of the United States, the Navajo Nation. So this is highlight number 3. How are researchers in the Navajo Nation using GPM data? Well, they're looking at longer term trends of precipitation data to track precipitation anomalies. So precipitation that goes outside the normal average rainfall. Why that helps? It helps understand the climate in the southwest region of the US so they can start to make water budget assessments. This helps aid in assessments of freshwater resource mitigation strategies, such as rainfall harvesting, to even sending out drought early warning systems throughout the reservation to communities to understand when water is very scarce in that area. Still sticking to the agriculture theme, I'm going to highlight number 4, and this is talking about supply chains. We have a company called Nutrien. They're a big agriculture company, and they are monitoring precipitation impacts on crop demand throughout the world. And this one case study has to be, is in the region of China. And so there was a huge precipitation event and impacted, I believe it was wheat in that area. Now that has a huge impact downstream. Why? Because we all rely on food from throughout the world. And so that could have an impact on the global supply and demand of food and increase prices. So they're really actually looking at supply chain disruptions based on precipitation data. All right, number 5, now we're switching to public health. We have many people that are researchers that are using precipitation data from GPM to look at vector and waterborne diseases. One example on the vector side is that mosquitoes can carry malaria, and a disease that can impact us, or vector-borne disease that can impact us and hurt us very easily when you're by mosquitoes. But why is this important? Where does precipitation come to play? Well, we need to understand what rainfall is, because when there's standing water, mosquitoes love that area, those air conditions. They love to thrive in those, and it's favorable for mosquito breeding and survival. Knowing those areas that are most prone to have those mosquito breeding grounds can help send public health alert officials alerts to help inform communities about taking measures to reduce impacts of being bitten by a mosquito. Now, switching over to the disaster response side, highlight number 6. What are people doing with this? Because of the timely data of GPM, people can get information within 4 hours and even 10 hours. Both of those play a central role in disaster monitoring. So what you have here in the Philippines, a very extreme precipitation event occurred, and the Emergency Response Coordination Center out of the European Commission uses precipitation data, overlays it with other key socioeconomic data. This becomes critical for humanitarian aid organizations to go to the areas that are most needed and effectively pass out aid in an effective manner based on the hazard that the flood or the disaster created. Excuse me. Okay, highlight number 7. Still within kind of disasters, but we're really focusing on the weather forecasting side, is in hurricane warnings. What's really cool, and I didn't really mention this at the beginning, as a reminder, not only does the GPM mission provide this global precipitation data, we have the capabilities from our satellite, because of our instruments, to see inside a storm. And so we can see the 3D structure, we can see what is going on in the behavior, but also from looking at some of the data that is coming from those instruments can provide critical information. And so when our satellite passes over a storm such as a hurricane, it can help us understand more about the cyclone track, the behavior, look at eye wall formation. All of that has critical information to weather forecasters to send early warning alerts. And so in this picture, you actually have a screenshot from the Naval Research Laboratory along with NOAA. So both part of the US side that works with hurricane forecasting, that's showing how valuable the GPM data sets were for hurricane prediction. In the top left is actually showing the idea where the information from one of our instruments was so critical that it actually improved the forecast skill of when a hurricane made landfall in Portugal. And so that if you have time or more accurate forecasts, it gives us a lot more time to prepare than if we didn't have that. All right, highlight number 8, generating landslide risk assessments with GPM data. We have researchers at Goddard that have developed a tool to look at, based on precipitation of an area that is most likely to have a landslide occur. So folks, especially in the transportation industry in Oregon, for example, the Department of Transportation, are very interested to see how this tool can be used to generate landslide hazard probability maps. So they can show and actually use that as a source of information and send those warnings throughout the roads because it's landslide prone areas in Oregon. Highlight number 9, moving to the energy side. One thing, I think this is a very unique one. As I mentioned, our instruments on board the GPM satellite can really see inside a storm, but they also can tell the difference between rain, or light rain, heavy rain, and snow, really looking at the different phases of precipitation. And so what an energy company is doing is assessing the impacts towards the wind turbine blades, from hail impacts to snow to water offshore. Why? Because they're trying to come up with strategies to mitigate the erosion on these turbines based on the climatology of precipitation. And they develop actually a sealant to help protect the turbines over a certain amount of time based on precipitation. And last but not least, I'm still sticking to the power side because I wanted to shed light on the many users that actually incorporate GPM data into their own web application interface. So what you see here is actually the power project, the prediction of worldwide energy resources. This tool is actually developed out of NASA Langley, I believe, and it helps support the renewable energy in a very effective way. Why? GPM data, because we have this over 20-year record, is helping to support decisions on planning energy generation, grid management, resource allocation to meet usage demands. But this is also, they're also starting to see that this is used for infrastructure siting, design, and management. We're seeing that actually in Indonesia too, and also assess weather risk decisions based on energy infrastructure and development in those areas. And all this can be done through this tool. You can access one of our data products from GPM through this tool. And it's a really cool, powerful interface for organizations that want to support the renewable energy side. All right, I'm pushing time, so I just want to go quick with this, is that there's some fantastic resources we have on our website from one-pagers that kind of describe a little bit more about case studies and the capabilities of GPM data and how to access GPM data. We have application packages, some really cool sets depending on thematic areas, from the disease initiative that highlights how GPM data is used for vector and waterborne diseases. This will all be part of Dorian's resource packet. We have others. We have the agriculture insurance. How exactly is GPM data being used in the insurance side in benefiting smallholder farmers throughout Central and South America? We have others in the ecological management. How are people using this GPM data as input into their animal tracker systems? And last but not least, we have a cool resource packet on how GPM is supporting climate modeling activities. And here's a QR code. I'll take 1 second, but again, this will all be on the resource packet. And then I will wrap up with, there's some also highlighting STEM careers that you can access to. And I will show you, here's a QR code. So I think I'm gonna actually stop there with timing. And if anyone has any questions or comments, I'm happy to answer at the end. But yeah, I'll stop there. Thanks, Dorian.
Thank you very, very much, Andrea. And if you take a look in the chat box, there are some questions. And if there's something that somebody's asking you about one-pagers, So yeah, if you'll jump on in there and answer some of those questions. And thank you very much. That was a wonderful overview, a kind of a top-end view of the incredible variation to the ways in which this freely available data is being used by people all over the world for so many different applications. We do hope you'll get a chance to jump into that resource packet and take a look at some of the varied applications. In that resource packet, we've also included some lesson plans and some educational resources that can be used to help people better understand how and why we are working with end users to be able to use this data. So next, we're going to be hearing from Anita LeRoy, and she is going to be giving us a bit of a deeper dive. So without further ado, Anita, I'm going to I'm going to keep my sound on, and I'll let you know when I see you in presentation mode. You're looking good. Thank you. Perfect. Oh, we can't hear you though. We can see you, but we'll get just figured out here. We could hear you before. Let's see if I can unmute.
There we go.
All right, brilliant.
I was muted. So sorry. How are we looking?
Perfect. Thank you.
Great. So now we can jump right in. So I work for a group called NASA Sport, and I'll be telling you a little bit more about that in a second. But just to sort of take a step back, when I'm talking about applications in my talk, I'm really talking about the weather forecasting and monitoring and communicating risk to the general public. So that's really kind of where I'm at, these real life weather challenges. And since we're talking about GPM as they relate to precip, so stuff like flood, droughts, landslides, and data voids. This is a challenge. I'm going to talk about this term a little bit. The gold standard for understanding where precipitation is happening on, the United States is like a ground-based radar system. If you've ever gotten an app so you can pretend like you're tracking tornadoes or something, you're familiar with ground-based radar. You can't put a ground-based radar, for example, in the ocean. So that would be a data void. We want to know what's happening in places where we don't have good ground-based data. And that's where satellites really, really shine. So GPM helps to solve all those different challenges that were on the last slide. You've probably heard a lot about how GPM is a satellite precipitation science satellite mission. And science is great because it enables so many different applications. So it's taking all these observations globally. It doesn't have the limitations that a ground-based radar would have, so it can get precipitation all over the world. It's also intercalibrating against a lot of similar satellites with similar instrumentation. So you can use all those satellites together to get really good precipitation estimates from space frequently because there's so many of them. And GPM is kind of unique in NASA instrumentation. They're allowing us to get that data very quickly. So as close to the observation time as possible. All of that is very, very good, but it does present kind of a new challenge. Weather research and science versus operations and forecasting. We have completely separate data infrastructure on the research side versus the operations and forecasting side. So your weather forecast offices can't easily get certain types of data into their systems and their software. They already have their own visualizations. By its very nature, an operational forecasting environment, it's not quite as flexible. It's a little bit more reliant on a standard operating procedure, proprietary software, stuff that makes it very, very easy for them to integrate all their different things on one screen. So I can't just send them to a website and have a forecaster go, oh, I'll just exit what I'm doing, go to your website to look at the rain, and then come back. We have to find a way to sort of bridge this gap and understand what their workflows look like, what kind of formats and things that they need, so that we can provide data directly into a decision support system or a software or a visualization tool that they have. So cutting edge solutions like GPM and other satellites, they could have a huge impact on weather forecasting and operations. But we have to do this thing, right? We have to go from all the bits and bytes on research satellites and bring them to the people who are actually doing the forecasting, whether that's your favorite person on TV or an app. go gadget sport paradigm. That's exactly what we do. So NASA SPORT, that stands for the Short-Term Prediction, Research, and Transition Center. Yes, really it does. Don't know where the O comes from. So NASA SPORT, it's easy to say. It was founded in 2002. We exist in Marshall Space Flight Center in Huntsville, Alabama. This was when there were these two new Earth-observing satellites called Terra and Aqua being launched. Terra and Aqua had this really good instrumentation that could really help weather forecasting, especially. But there was no way to get that data into forecasting. So some folks established this program, the center here at Marshall, to take that research and satellite data for methodology and then bring that stuff into operation. So that can involve reformatting the data, doing something really simple, or developing visualizations to incorporate that into their existing workflows. It can involve sort of making new products out of the data, value adding it, changing certain things about it to make it easier to see things quickly. We also provide training and assessment, and we're constantly improving. So we go through these assessment procedures where we see if it's working in their workflow and if it's doing what they expect it to, and if it's providing value, which is very important. If it's not, either we try to improve it or we pull the plug. If it's not helpful, then they don't need to keep having our data shoved into their system. But what we really go for is sustained use in operations. So things like NASA research data into operations. Here's one of the partners that we work with. This is an image from the Weather Forecast Office in Juneau, Alaska. They cover a pretty broad area, but the Southeast Alaska area is one of the most beautiful places you can go to in the world. You'll be on an island and you'll go from sea level to about 3,000 feet elevation, like within 300 feet of the coast. That's kind of a problem. They get lots and lots of rain in Southeast Alaska. And when that rain interacts with the orography or the mountains, then they're very prone to landslides and to significant flooding. It's also like a very good example of a data void region. All those little spotlights you see are where they have ground-based radar. Alaska is a big place, and not very much of it is actually covered by ground-based radar. So without satellite information, they really wouldn't know that much about what the precipitation is happening. Now, Juneau, Alaska is that one on the bottom right over all those islands. Another limitation of ground-based radar is that it can't see through a mountain. So if you've got a radar in the center of that circle, like that circle right there, for example, it's really getting an idea of what that precipitation is in the ocean, but not really at all in all those islands. And that's a problem because those islands and all that land, that's where the people are, right? So we need to be able to understand where the precipitation is happening, where it's going to impact people and interact with that orography and actually create risk. For comparison, that's the satellite data, the GPM satellite data that we were able to provide in the same decision support system that they're already using for that same case. So ground-based radar it's wonderful if you can get it. It's very detailed, but it's not exactly even showing where all the rain is at, right? So here's our satellite image for that same area. It's a bit blockier because it's got a poor resolution, but it is showing the intensity of the rain. So if you know where the heavy rain is happening in this orography, you can prepare people. So that's really what the impact is. Because they were able to get this data into their decision support system, the forecasters were able to sort of change the way they were providing guidance and warnings for landslides so they could communicate to their communities what was possibly going to happen, that they've got the heaviest rains in certain locations. And those locations could choose to maybe close roads or something, or the people there could decide if they needed to move to a different location. Ultimately, that saves lives. So that's a really incredible impact we have. The other partner that I'm going to talk about today is the U.S. Drought Monitor. The monitor isn't like an instrument or something. It's actually a program where there are several specialists who use lots of different radar, satellite and radar assets to observe precipitation across the United States and U.S. territories and places that the United States cares about. And once a week, they write the drought report, the U.S. Drought Monitor report, and they ascribe intensities of drought to locations that have been experiencing drought. These intensities are sort of important because, for example, if we've experienced a drought in the Midwest and we know that there's damage to the corn crop. If it's a certain intensity, first of all, that can free up certain types of aid. So you can get maybe like farm aid or something to those farmers who are financially impacted. It also helps us strategically prepare for possibly not a lot of corn coming to market. So it's kind of important to know agriculturally where our drought is really, really bad. There's also lots of other resources that you can move for, like wildfire risk, for example. So 2023 was an El Nino year, and it brought drier than normal conditions to the Pacific Islands, including Micronesia, resulting in some of these islands having exceptional drought. The challenge here really is that even if you could put radars across some of these islands, rain is so spatially variable that there are winners and losers in the rain game, right? So there are some of these islands that are in white, they didn't have drought conditions, and some of the islands in the red and dark red had really, really significant exceptional drought. One of the reasons that we care about some of these islands, there's one in particular, Yap Island. The U.S. Air Force is updating an airbase there. And if they're experiencing water stress, and they were very significant water stress, the people who live on those islands did not have drinking water. You probably don't want to drop a bunch of U.S. soldiers or contractors on that island sucking up more resources, right? You need to be able to plan that appropriately. So the drought monitor monitoring all these places was able to ascribe appropriate intensities using NASA iMERGE, which is a GPM product that we provided specifically for them. They wanted a certain cutout and a certain layout, and they wanted specific accumulations. So we were able to provide that data for them so that they could write their drought reports on these islands where they didn't have a lot of other information. So again, the impacts of the drought are things like water scarcity, wildfires, crop loss in some of these islands. But being able to update those drought intensities specifically for Micronesia now, the Federated States of Micronesia declared a national emergency. They were able to apply for disaster relief. UNICEF became involved and provided water resources. So being able to rapidly mitigate these exceptional circumstances and prioritize where resources need to go, it's one of the great values, one of the good, solid impacts that we're getting from being able to do this work. Here are some big takeaways if you take nothing else away. Bringing research to applications isn't always straightforward or easy, but the impacts are incredible, and we want to be able to continue to do that. And GPM has many applications that impact our lives. Yes, your life is made better and safer by things that we're doing with GPM right now. We're using it across the globe. In NASA Sport, my little slice of the world, we specialize in bringing cutting-edge weather data and land observations and air quality data to operations and forecasters. So if you wanted to learn more about NASA Sport, got two websites. On the regular main page, you can find real live data streams. We have a sport blog. You can follow us on Twitter, and you're welcome to reach out to me.
Wow, thank you so much, Anita. It's really neat to hear from Andrea, kind of that big view, and then to go in more closely and get a sense of, the many ways in which you're looking at this data more closely, and the ways in which you're also, bringing together that ground data, that ground, based data as well. Loved seeing all these questions. Thank you so much, Andrea, for putting in there a bunch of links and guiding people to learn more. It's impossible in a 1 hour webinar to be able to really bring to you the breadth and depth of all the things that are out there. So keep asking these questions, and we'll keep trying to pour in more places where you can go and learn more information. And now it's my great pleasure to bring our dear friend and colleague, Vasco Mantas, here to give us a little more information about these applications and these user communities. So thank you. And we are seeing you beautifully. Well, we're seeing your screen beautifully. And you as well. There you go.
Thank you so much, Dorian. Hello, everyone. Thank you for the invitation to participate in this amazing webinar series celebrating GPM's 10th anniversary. And today I will be describing on a very high level the experience of my team and partners on the attempt to mitigate data gaps using satellite data from the GPM mission, but also other missions in support of sustainable development and a better management of scarce natural resources, especially in mountainous regions. I understand many of you in the audience are not necessarily scientists, so I'll try to put the emphasis on the implications and reasons behind some of the decisions we made during our research projects. So I live in Europe, in Portugal, but I started conducting field work in the Peruvian Andes 10 years ago in partnership with local researchers from the University of La Molina. One of the regions I like the best is the region of Lake Junin in central Peru at an altitude greater than 13,000 feet or 4,000 meters. And I like that area particularly because of its beauty, the welcoming communities, and how the challenges that competing interests from mining to energy production, livestock, can have on conservation efforts and the lives of those who call that part of Peru and the Andes their home. And the Andes Mountains are extremely interesting region. They stretch over or across multiple countries in South America and are a very challenging but rewarding place to conduct science and work in sustainable development challenges. The complex topography makes it harder to create high-quality satellite products, including precipitation products like the ones shown in the previous presentations. And the climate variability and the impact of El Nino can lead to significant differences across years and across regions, often generating disastrous conditions with extreme precipitation, alternating with devastating droughts. So water resources are critical as they are everywhere, but in this region, they are particularly challenging to manage, protect, and even more to predict what the future holds in terms of availability and quality of some of those resources due to the impact of climate change and even the tipping points elsewhere in the Amazons or the collapse of ocean currents in the Atlantic. And so this is a context that can lead to conflict that can often become violent and disrupt the lives of the people and the stability of the communities in that part of the world. Conflict in this context also often arises from a lack of informed or transparent decision-making, and this is where data from satellites can have a particularly important role. We are talking about very rugged terrain, and precipitation, for instance, can vary across very short time and spatial scales. So having satellites collecting data that we can use to estimate the amount of precipitation for any given area or study the processes that are driving precipitation and trends can be essential to help us work with stakeholders and inform decisions. So satellites like GPM are essential to communities around the world and to enable them to access critical data that they can and should combine with other data sources, including data from conventional weather stations, radars, numerical models, and maps of all types to give us an integrated view of essential information needed to drive sustainable development. And in many regions, mountainous regions, island states, and even less remote parts of the world are experiencing for the first time in years or even decades a reversal of development trends due to the increasing number and impact of disasters. Weather and water-related disasters are particularly punishing, and we need to keep an eye on them and be able to monitor those disasters efficiently. And to do this and to have this connection to the communities and to decision-making, we envision applications as a cycle where different components work together to advance our knowledge and our ability to translate that knowledge into solutions. This requires trust. It requires trust and the active involvement of stakeholders from government agencies to local nonprofits. It starts with the science and the need to answer complex questions and understand the underlying processes, but it continues with guaranteeing that we have the necessary technological resources to process and distribute the data and the results. And of course, we cannot forget the policies that are used or adopted to share the data, and also how we can incorporate the new knowledge that is being generated into the policy instruments needed to effect change. So with this in mind, I will walk you through an example of a project that we have been implementing in the Andes in collaboration with local universities and agencies, and that is part of a multi-year initiative. And our main science question is, how does precipitation variability affect ecosystem services and the management of natural resources? And the first step is to find the appropriate data already available. In the region of Lake Junín, we have limited coverage by conventional weather stations. We have no coverage by weather radars. So this reality calls for the use of other sources of data to provide us with the necessary precipitation data. And we selected GPM iMerge, and this product was already mentioned before today, because it's a global product, very high quality product, and the temporal resolution of 30 minutes makes it ideal to our objectives. But before using it, we had to understand its strengths and limitations for this region. And to do so, we compared it with rainfall gauges, and conducted what we call a ground validation using a large number of precipitation gauges across Peru and Chile. And this study showed that performance, as expected, is spatially heterogeneous, but also demonstrated the high quality of the GPM iMerge product. However, some information did not exist at all. And or if it did not exist with the level of detail required to answer our questions or to meet the needs of our users. To study, for instance, the vegetation dynamics in this region and understand the role of precipitation in changing distribution, phenology, and even the physiological status of plants, we need first to have an accurate representation of the land cover. We need to know where the plants are. And so global land cover models do exist and are available, but they often fail to represent the specific vegetation types that we need to analyze. So to close this gap, we created a new model using data from different missions that also provide us with the distribution of surface water extent, which varies substantially throughout the year. Combining this data with the precipitation data from iMerge allowed us to find correlations between vegetation dynamics and precipitation, and also launch demonstrator applications that provide estimates of available lake volume. Now, all these efforts are pointless if we fail to distribute the data and results in an open and accessible way. To achieve this, we worked and continue to work with the users to understand their requirements and operational constraints. Do users know how to code, or do we need to develop dashboards? Will the users integrate our data with their own to derive insights? And how can we go from data and even information to insights that can actually shape policy instruments? Those were all discussions that we had with stakeholders. We continue to have those discussions, and with the help of experts from the social sciences, because stakeholders represent the future of all these efforts well beyond the end of the projects or even of missions like GPM. So we need to work with stakeholders to ensure there's continuity in this type of efforts and this type of research and applications. So this ongoing dialogue and active engagement with stakeholders did allow us to create a community with trust being reinforced and the adoption of the data streamlined. And this includes development of policy briefs, promotion of capacity building initiatives, and of course, a very huge focus on continuity, because that's key to a lot of our users. Of course, the work with users and our role as intermediaries does not end. It starts, it is pretty much a continuous effort that must start and focus on the joint definition of application priorities. And it must be emphasized that a successful strategy cannot focus solely on, sometimes we call power users, because quite often smaller organizations can have a disruptive impact on communities and conservation, and their participation is also critical. And repeat, once the question is answered and the new data is generated, new insights, new discussions will raise even more questions and the opportunity and the ambition to develop new and better research and applications. So this is really a never-ending story that continues and is ongoing. An example of an application we developed as part of our exploratory ENDs project was a machine learning-based model that estimates the available lake volume. To achieve it, we integrated data from multiple missions, including GPM iMerge, which was actually at the core of this solution, and but also the land cover models and the surface water extent models to provide additional input, resulting in a highly reliable all-weather solution that can be used in support of the decision-making process. This type of regional demonstrator applications are critical to slowly raise awareness and interest from the users to the adoption of the Earth observation technologies and of data from missions like GPM in particular. Prototyping solutions is also a great way to create a very dynamic work environment with the active participation of multiple actors across disciplines. So with this work, we actually concluded the exploratory stage, which lasted for about 3 years. And now we received funding. We're just starting to expand into new watersheds and scale up our research and applications to different environments across altitude, land cover, and precipitation gradients across the Peruvian Andes. We'll also formalize a framework for stakeholder involvement through the establishment of water-oriented living labs, where we are establishing new and very dynamic innovation ecosystems. Ideally, at the end of the new Gradientes project or Gradients project, we'll have answered important scientific questions regarding precipitation variability and ecosystem services, but also launch several operational applications that can actually support sustainable development and conservation efforts. So this is what I have to show you today. And I thank you once again so much for your attention and for the invitation to present. Feel free to reach out if you'd like to learn more.
Wow, Vasco, Anita, and Andrea, thank you so much. Really gave us this, this broader view, and then even diving in deeper and looking at some of the ways in which the use of ground validation it is being used, as well. As I was looking at the chat, I thought of something that came to me in thinking about the question, how can you, as just kind of, not just as an average citizen, be involved as well? I put in there a link to the GLOBE program and GLOBE Observer app. Those are some of the ways you could be involved. And I was also thinking, for those of you who, for example, in Maryland, we had a really, really dry July. And something that you could do is you could look at the GPM precipitation data for the last 24 years. Just use the link I put in earlier, and Andrea had put it in too, from satellites to your backyard. You put in your longitude and your latitude, and you can get your seasonal, yearly, monthly data for the last 24 years and take a look at what the patterns and trends of precipitation seem to be. Then you could think about the trees that are in your environment, the vegetation. You could look at what the International Panel on Climate Change, IPCC, anticipates will be the changes that you'll be seeing in weather patterns. And you can start to kind of line those things up, do your own kind of ground validation, maybe have a rain gauge and be keeping track of it and be comparing that to the norms. And if it seemed like something where you find that your community needs to be engaged in making some changes to be more sustainable and to adapt to some of the changes, you can be a stakeholder and be a change agent in bringing about some change in your communities. So don't think of this as just being for the scientists. All of us are scientists. All of us are observers. And so find some of these things that seem interesting to you and jump on in and give it a try. Wow, Vasco, I see that you got a chance here to take a look at some of the comments, and Andrea and Anita as well. Let's see, I'm trying to see if there's any questions. Agatha may have had a question. Good, thank you so much.
I think, Anita, I think this could be addressed to you if you don't mind. So it's asking, do you also measure the pressure systems that have centers and are associated with precipitation causing air rise and cool, leading to cloud formation and condensation?
So yeah, as a field of study, those are things that are measurable from space from a variety of different platforms. A lot of that stuff, though, when it comes to and I'm speaking from the perspective of weather forecasting, so much of that is driven by the models. Now, this is also something that GPM is good at. All that well-calibrated data goes into modeling, and that helps us really get a good sense for cloud formation and pressure systems as well. So stuff like tropics. I didn't have enough time. I felt like I didn't have enough time to squeeze in tropical weather and hurricanes into my talk, but we also provide data to the National Hurricane Center and to other entities that do tropical forecasting so that they can look at the way storms are formed and what they can divine from that.
Thanks, Anita. Dorian, I know a few people keep on asking about presentations. Do you want to reiterate what would you like to do moving forward?
Certainly. So if you will send me an email, actually, sometimes I just have to ask the speakers, are you okay if we put your presentations in PDF format on the website that people went to register for this webinar? That's the easiest way for people to be able to access your presentation.
I am, but yeah, we can take it. If we're okay for some of us, if we're okay with that, then sure, we'll send it your way then, PDF format.
Sounds good. And then I'll reach out to our web designer and ask him if he'll stick them up there. So the same link that you went to very good. What I will also do is I'll put the link in the resource packet, because I really like to kind of make it so that it's seamless for you all, so that basically you can go to this resource packet website and find everything. The recording will be posted there sometime tomorrow. Thank you so much for taking care of that, Andrea.
And I will stop recording now.
Good, thank you.